Okay, ready for another one? So now we're dealing with cosine and we have inverse sine on the inside. So again, we're gonna work this way the same way that we've been doing before. Okay, so now here we've got x. So now the one difference is now they're putting x in here, some variable x. Okay, but again, this whole thing is the angle. Okay, or this whole thing is the angle. Okay, this is the ratio. So, and this is the values of x that we're defining this for. Okay, now keep in mind, again, we don't want to lose track that for the sine function, right? For inverse sine, the interval, okay, right, the domain has to be from negative pi over 2 to pi over 2, right? Okay. Okay, so just keep that in mind. Okay. Oh, this is for sine, right? So again, we know that the inverse sine must have an angle that's between these two, right? Because that's the restricted value on sine, right? Theta is between these two, so we know that that's going to be restricted. They're also giving us a restriction on x in this case. So what we're going to do is we're just going to do this the same way. Now I'm going to use the Pythagorean identity in this case, but you could do it using the right triangles again, okay? So the first thing I'm going to do is understand that this is an angle, right? Again, inverse functions or inverse trig functions are angles, right? So I'm saying theta is equal to sine inverse of x over 3, which means sine theta is equal to x over 3. Now this is where you can say this is opposite over hypotenuse, and you can set up your right triangle, but I'm going to use the Pythagorean identity. Again, it'll work either way. So now I'm going to set up the identity, so I know that sine squared theta plus cosine squared theta equals 1. And sine theta equals this, so I'm going to do x over 3 squared plus cosine squared theta equals 1. And so this equals x squared over 9 plus cosine squared theta equals 1. And so now I'm going to subtract from both sides. So I'm going to get cosine squared theta equals 1 minus x squared over 9. Okay, now I'm going to make this into one fraction, right? Because I'm going to be taking the square root of that, and I want to be able to simplify the top and the bottom. Because if I can get a common denominator on the bottom, then I can take the square root of 9 and be done with the bottom. And then I'll just have to deal with the top, which there won't be anything I'll be able to do with it. But it'll look simpler, okay? So now if I come down here, and I'm going to write this as cosine squared theta equals 1 minus x squared over 9. And so if I take the square root of both sides, I get cosine theta equals plus or minus the square root of 1 minus x squared over 9, which then gives me what? Plus or minus the square root of 1 minus x squared over 3. Okay, now, so guess what? I just found cosine theta. So now the thing is if x is between -3 and 1, that means this is going to be between -1 and 1, right? Which is exactly what the domain of inverse sine is, right? -1 to 1. So that should be a surprise, right? So that's awesome. So that's exactly what we want. So that's good. So now, cosine is, now the sine here, sine of theta is x over 3. And that ranges from -1 to 1. So that means that inverse sine goes from what? It goes from negative pi over 2 to positive pi over 2. And so we get this. Now, as far as the plus minus, in this case, since we have to be in between negative pi over 2 to positive pi over 2, right? And notice that this is positive, and x let me think. Pi over 2. Oh, yeah, well, yeah, because this is from negative pi over 2 to positive pi over 2. This is in the first and second, this is in the first and fourth quadrant. So this has to be positive. Because cosine is positive in the fourth and first quadrant. And that's it. Have a great day.